4 other ships with this name. See Savannah #ships. NS Savannah was the first nuclear-powered merchant ship, built in the late 1950s at a cost of $46.9 million, including a $28.3 million nuclear reactor and fuel core. Funded by United States government agencies, Savannah was a demonstration project for the potential use of nuclear energy. Launched on the 21st of July 1959 and named for SS Savannah, the first steamship to cross the Atlantic Ocean. She was in service between 1962 and 1972 as one of only 4 nuclear-powered cargo ships ever built. Savannah has been moored at Pier 13 of the Canton Marine Terminal in Baltimore, Maryland since 2008. Creation. In 1955, President Dwight Eisenhower proposed building a nuclear-powered merchant ship as a showcase for his Atoms for Peace initiative. The next year, Congress authorized Savannah as a joint project of the Atomic Energy Commission, the Maritime Administration, and the Department of Commerce. She was designed by George G. Sharp, Incorporated, of New York City. Her keel was laid down by the New York Shipbuilding Corporation at Camden, New Jersey. Her nuclear reactor was manufactured by Babcock & Amp Wilcox. She was christened by U.S. First Lady Mamie Eisenhower at the ship's launching on the 21st of July 1959. In 1969, Savannah became the first nuclear-powered ship to dock in New York City. She was a centerpiece for a city-wide information festival called Nuclear Week in New York. Thousands of persons toured Savannah and the other special events of Nuclear Week in New York. These events included demonstrations of advancements in peaceful uses of atomic energy, such as food products purified by radiation, new applications for technology, and many information and education programs. The Johnny Carson Tonight TV show featured Nuclear Week in New York on 2 programs. Dr. Glenn T. Seaborg, chairman of the U.S. Atomic Energy Commission, was the featured speaker, and President Eisenhower was honored for his introduction of the Global Atoms for Peace program. The appearance of Savannah and the Nuclear Week in New York program was designed and implemented by Charles Eulish Associates and supported by contributions from leading energy companies. Concept: Eisenhower desired a peace ship that would serve as an ambassador for the peaceful use of atomic power. According to an Eisenhower administration statement to Congress, the president seeks no return on this vessel except the goodwill of men everywhere. Neither will the vessel be burdened by proving itself commercially feasible by carrying goods exclusively. Quote, although initial proposals used a copy of US Nautilus's power plant, a conscious decision was made to design a propulsion system with no connection to military programs, to commercial design standards. George G. Sharp, Inc. is a prominent naval architecture firm in New York City, founded in 1920. George G. Sharp was responsible for Savannah's design in all respects, apart from the nuclear reactor, designed by Babcock & Amp Wilcox. Savannah was the 6th large ship to have fin stabilizers intended to enhance the safety of the reactor and to improve passenger comfort. Since the reactor occupied the center of the ship, and because the reactor required clear overhead access for a crane during refueling, the superstructure was set far back on the hull. The raked, teardrop-shaped structure was specifically designed by George G. Sharp's ship design consultant Jack Heaney and Associates of Wilton, Connecticut, for a futuristic appearance, decorated with stylized atom graphics on either side. Heaney was responsible for the interiors, which featured sleek modern styling appropriate to the atomic age. Description: Savannah measures 596.5 5 feet in length and 78 feet in beam, with a loaded draft of 29.5 feet, and a loaded displacement of 21,800 tons. Savannah was built with 7 cargo holds, a reactor compartment and a machinery compartment, making 9 watertight compartments. There are 3 full decks. The reactor compartment is located near the center of the ship, with the superstructure just aft of the reactor top to allow the reactor to be refueled. Holds 1 through 4 are forward of the superstructure, with cargo handling gear between 1 and 2 and between 3 and 4. Cargo hold 5 is served by side ports, as it is located beneath the swimming pool. Holds 6 and 7 are aft of the superstructure. The topmost deck of the superstructure comprises the pilot house, radio room, chart room, a battery room and an emergency diesel generator. The next lower deck comprises the officers' accommodations, with an officers' lounge at the tapering rear portion of the superstructure. Below this level is the promenade deck comprising, from forward aft, the elliptical main lounge, the main stair and elevator, and the veranda lounge. The bar was provided with enclosed walkways outboard, and a glass wall overlooking the swimming pool and promenade deck aft. A dance floor was provided in the center of the lounge, surrounded by tables with illuminated glass tops. The back bar features a glass and metal sculptural interpretation of the periodic table of the elements. A deck is the first full deck level, with cargo handling facilities fore and aft. Deck surfaces have been retrofitted with cargo container anchors. The interior of A deck contains the main lobby and purser's office, the infirmary, barber, beautician and steward's facilities, as well as the health physics laboratory intended to monitor the effects of the nuclear reactor. All 30 passenger cabins are located on A deck, each with a private bath and accommodations for 1 to 3 passengers. B deck contains the ship's kitchen and the dining room. The 75-seat dining room features a curved wall sculpture entitled Vision by Pierre Bourdelle. At the opposite end of the dining room, a metal model of the SS Savannah is set in a glass panel. The overhead light fixtures are screened with brass bands representing stylized atoms. The kitchen features an early water-cooled Raytheon Radarange microwave oven. B deck also includes crew quarters and the crew mess and lounge. C deck comprises more crew quarters, the laundry and a butcher's shop. A glassed-in central gallery provides a view of the main engine room. A pressure door provides access to the upper levels of the reactor compartment. D deck houses the machinery spaces, cargo holds and the nuclear reactor. Reactor Savannah's reactor was designed to civilian standards using low-enriched uranium with less emphasis on shock resistance and compactness of design than that seen in comparable military propulsion reactors, but with considerable emphasis on safety and reliability. The reactor was placed to allow for access from above for refueling. The 74MW reactor is a tall, narrow cylinder, housed in a cylindrical containment vessel with rounded ends and a 14-foot diameter vertical cylindrical projection housing the control rods and refueling equipment. The 50-foot-long containment vessel houses the pressurized water reactor, the primary coolant loop and the steam generator. The steel vessel has a wall thickness varying from 2.5 inches to 4 inches, designed to accommodate the 186 psi pressure generated by ruptured primary coolant pipe. There are two 42-inch diameter manholes in the top of the containment vessel, two 24-inch by 18-inch manholes in the bottom of the containment vessel are designed to admit water to the containment vessel if the ship sinks in more than 100 feet of water to prevent the pressure vessel's collapse. The containment vessel was not occupied under operational conditions, but could be accessed within 30 minutes of reactor shutdown. The lower half of the containment vessel is shielded by a 4-foot concrete barrier. The upper half is shielded by 6 inches of lead and 6 inches of polyethylene. A collision mat shields the sides of the vessel with alternating layers of 1-inch steel and 3-inch of redwood in a 24-inch assembly. The reactor was defueled in 1975, but the reactor remains in place. The reactor is 17 feet high with a core 62 inches in diameter and 66 inches high, with 32 fuel elements. Each fuel element was 0.5 inches in diameter and housed 164 uranium oxide pellets enriched to an average of 4.4% U-235. The 16 center elements were enriched to 4.2%, and the outer 16 elements to 4.6%. The pellets were 0.4244 inches in diameter, with pressurized helium gas in the annular space between the pellets and the element walls. 21 control rods were provided, 66 inches long, 8 inches across and 0.375 inches thick. The rods could be fully inserted in 1.6 seconds by electric drive. Machinery. The main machinery room measures 55 feet long by 78 feet wide and 32 feet high. The main control room is immediately after the machinery room, from which engineers controlled both the reactor and the steam propulsion plant. A window separates the control room from the machinery room. The control room is visible from the viewing gallery on C deck above. The steam plant is a relatively standard steam plant in its general characteristics, with a 9-stage high-pressure turbine and a 7-stage low-pressure turbine driving a single propeller shaft. The turbines were specially adapted to use the saturated steam typically provided by a nuclear power source. It was also unusual in having a 750 horsepower electric motor geared to the high-pressure turbine for use in an emergency. The motor was driven by either the ship's steam turbo generators of the 750 kilowatts emergency diesel generators located in the rear of the pilot house. These generators could provide basic propulsion to the motor while running the reactor coolant pumps. The motor was upgraded to provide greater torque and reversibility to allow it to move the ship away from a pier in the event of a reactor accident. The propulsion plant's design capacity was 20,000 horsepower for a design speed of 20 knots. Actual performance yielded about 22,000 horsepower and a maximum speed of 24 knots. Economics of nuclear propulsion. Savannah was a demonstration of the technical feasibility of nuclear propulsion for merchant ships and was not expected to be commercially competitive. She was designed to be visually impressive, looking more like a luxury yacht than a bulk cargo vessel, and was equipped with 30 air-conditioned staterooms, a dining facility for 100 passengers, a lounge that could double as a movie theater, a veranda, a swimming pool and a library. Even her cargo handling equipment was designed to look good. By many measures, the ship was a success. She performed well at sea, her safety record was impressive, and her gleaming white paint was never smudged by exhaust smoke. From 1965 to 1971, the Maritime Administration leased Savannah to American exporters Branson Lines for revenue cargo service. However, Savannah's cargo space was limited to 8,500 tons of freight in 652,000 cubic feet. Many of her competitors could accommodate several times as much. Her streamlined hull made loading the forward holds laborious, which became a significant disadvantage as ports became more and more automated. Her crew was a third larger than comparable oil-fired ships and received special training in addition to that required for conventional maritime licenses. Additionally, a labor dispute erupted over a disparity in pay scales between deck officers and nuclear engineering officers. The pay issue continued to be a problem, so the Maritime Administration cancelled its contract with States Marine Lines and selected American exportist Branson Lines as the new ship operator. A new crew was trained, delaying further use for almost a year. As a result of her design handicaps, training requirements, and additional crew members, Savannah cost approximately $2 million a year more in operating subsidies than a similarly sized Mariner-class ship with a conventional oil-fired steam plant. The Maritime Administration placed her out of service in 1971 to save costs, a decision that made sense when fuel oil cost $20 per ton. In 1974, however, when fuel oil cost $80 per ton, Savannah's operating costs would have been no greater than a conventional cargo ship. In a note of historical parallel, the ship's namesake, SS Savannah, which in 1819 became the first steam-powered ship to cross the Atlantic Ocean, was also a commercial failure despite the innovation in marine propulsion technology. Nuclear fuel and waste. During her initial year of operation, Savannah released over 115,000 gallons of very low-level radioactive waste at sea, having substantially exceeded her storage capacity of 10,000 U.S. gallons. The nuclear servicing vessel Atomic Servant was built to receive waste from Savannah. The unpowered barge featured a fuel storage pit for a replacement fuel and control rod assembly, lined by 12 inches of lead. Atomic Servant was made available to service Savannah anywhere in the world. The radioactive primary coolant loop water was removed at the time of shutdown, as were some of the more radioactive components within the reactor system. The secondary loop water was removed at the same time. Residual radioactivity in 1976 was variously estimated as between 168,000 and 60,000 curies, mostly iron-55 and cobalt-60. By 2005, the residual radioactivity had declined to 4,800 curies. Residual radiation in 2011 was stated to be very low. The reactor and the ship will be regulated until 2031. Service history. After christening on the 21st of July 1959, it took another 2.5 years to complete the reactor installation and initial trials before the ship was moved to Yorktown, Virginia under temporary oil-fired power, where the reactor was started and tested. Full reactor power was achieved in April 1962. Savannah was delivered on 1 May 1962 to the Maritime Administration and turned over to her operators, the States Marine Lines. From August 1962, Savannah undertook demonstrations, first sailing to Savannah, her home port. During this trip, a faulty instrument initiated a reactor shutdown, which was misreported as a major accident in the press. Further, she passed through the Panama Canal and visited Hawaiian ports on the west coast of the United States, becoming a popular exhibit for 3 weeks at the Century 21 Exposition in Seattle. By early 1963, she arrived in Galveston, Texas for repair and system checks. There, a dispute over the compensation of nuclear-qualified engineering officers led to a reactor shutdown and strike by the nuclear engineering crew. The contract with States Marine Lines was cancelled and a new operator, American exportist Branson, was selected, requiring a new crew to be trained. resigned. This involved a switch to non-union crew, which became a lingering issue in the staffing of proposed future nuclear ships. By 1964, Savannah started a tour of the U.S. Gulf and East Coast ports. During the summer, she crossed the Atlantic for the first time, visiting Bremerhaven, Hamburg, Rotterdam, Dublin and Southampton. 150,000 people toured the ship during this tour. Savannah served as a passenger cargo liner until 1965, when passenger service was discontinued. By this time, a total of 848 passengers had been carried along with 4,800 tons of cargo. The ship was converted to all-cargo use with the removal of 1,800 tons of ballast. Passenger spaces were closed. Savannah operated for 3 years and traveled 350,000 miles before returning to Galveston for refueling. 4 of the 32 fuel assemblies were replaced and the remaining units rearranged to even out fuel usage. She resumed service until the end of 1971, when she was deactivated. During her active career, Savannah traveled 450,000 miles, visiting 45 foreign and 32 domestic ports, and was visited by 1.4 million people in her function as an Atoms for Peace project. Savannah's presence also eased access for nuclear-powered naval ships in foreign ports, though the ship was excluded from ports in Australia, New Zealand and Japan. Following her removal from active service, Savannah was first obtained by the city of Savannah and was docked at the end of River Street, with plans for eventually making her a floating hotel. However, investors could not be found. For a short period of time during the late 1970s, she was stored in Galveston, Texas, and was a familiar sight to many travelers on State Highway 87 as they crossed Bolivar roads on the free ferry service operated by the Texas Department of Highways. Museum ship. In 1981, Savannah was obtained via bareboat charter for display at the Patriots Point Naval and Maritime Museum near Mount Pleasant, South Carolina. Although the museum had use of the vessel, ownership of Savannah remained with the Maritime Administration, and the Patriots Point Development Authority had to be designated a co-licensee for the ship's reactor. Periodic radiological inspections were also necessary to ensure the continued safety of the ship. Once Savannah was opened for display, visitors could tour the ship's cargo holds, view the engine room from an observation area, look into staterooms and passenger areas, and walk the ship's decks. The museum had hoped to recondition and improve the ship's public spaces for visitors, but these plans never materialized. Savannah never drew the visitors that the museum's other ships, notably the aircraft carrier Yorktown, did. When a periodic MARAD inspection in 1993 indicated a need to dry dock Savannah, Patriots Point and the Maritime Administration agreed to terminate the ship's charter in 1994. The ship was moved from the museum and dry docked in Baltimore, Maryland in 1994 for repairs, after which she was moved to the James River Merchant Marine Reserve Fleet near Newport News, Virginia. The Maritime Administration has not funded decommissioning and removal of the ship's nuclear systems. Savannah had undergone work at Coloner's Shipyard of Norfolk, Virginia, beginning the 15th of August 2006. The $995,000 job included exterior structural and lighting repairs, removing shipboard cranes and wiring, refurbishing water-damaged interior spaces, and removing mold, mildew, and painting some of the interior. On the 30th of January 2007, she was towed to Pier 23, which is owned by the City of Newport News. On 8 May 2008, Savannah arrived in Baltimore under tow. Savannah may remain in Baltimore through 2016 under a U.S. Maritime Administration contract with the Vane Brothers Co. at the Canton Marine Terminal in the Canton section of Baltimore. Since Savannah is historically significant and has been designated a National Historic Landmark, MARAD has expressed interest in offering the ship for preservation once Savannah's decommissioning, decontamination and radiological work is completed. A MARAD spokesman told the Baltimore Sun in May 2008 that the Maritime Agency envisions the ship's eventual conversion into a museum, but that no investors have yet offered to undertake the project. Historic designation. Savannah was listed on the National Register of Historic Places on 14 November 1982. She was designated a National Historic Landmark on 17 July, 1991. Savannah is notable as one of the most visible and intact examples of the Atoms for Peace program, and was designated a National Historic Landmark in advance of the customary 50-year age requirement because of her exceptional national significance.